Hello my dear scholars, my name is Shiva Pratap Singh. Today I'm here to continue my lecture series on building materials. Click on the I button if you want previous videos of this lecture series. Today I'm gonna go through the study of lab test of cement. So lab test contain two types of test, physical test and chemical test of cement. Lab test contains physical test and chemical test of cement. Chemical test of cement. Today we are gonna go through the physical test. So physical test contain about 7 points. Physical test of cement contains about we used to do physical test on the basis of 7 points. And the first one is finest test. Finest test of cement. And then consistency test of cement. Test of cement. Third one is initial setting time and final setting time. Initial setting time and final setting time test. Okay. And fourth one is soundness test, then compressive strength test. Soundness test of cement, then compressive strength test of cement. Compressive strength of test, then heat of hydration test, and then specific gravity test. Okay, heat of hydration test, then specific gravity test. Okay, so first we used to discuss about the finest test of cement. Okay, so why we do finest test of cement? Finest test of cement is used to done for the gradation of cement. Okay, finest test of cement. Finest test of cement it is done for the gradation of cement. Okay, if finest cement is more, its specific surface would be more. Okay, if finest cement is more, its specific surface would be more, so more water will be get attached to the particle. Okay, what if fineness of cement is more, its specific surface is more, surface already would be more. Okay, so more water will get attached to the particle. Due to more quantity of water attached, hydration would be more, hence rate of early strength is more. Okay, so more water will get attached to the particle due to more quantity of water, there is water attached, more quantity of water attached, then hydration would be more. Due to more quantity of water is attached, then hydration would be more. Okay, hence rate of early strength is more. Strength is more. what it is all about. If fineness is more, then its specific surface is more. If specific surface is more, then hydration would be more. Okay, if hydration would more, then early strength would be more. Early strength would be more. This is all about. Okay. Now, one thing which is more important for the finest test of cement. Fineness of cement has no effect for ultimate strength. Look here, if fineness is more, specific surface is more, hydration is more, and early strength is more. But one thing which is most important, it is write down it by making a note. Fineness of cement have no effect. Fineness of cement has no effect on effect of ultimate strength. It only affects the early strength. Okay. If fineness increase, cohesive of cement increases and it reduces bleeding. Okay. If there is a increase in fineness, if fineness increases, cohesive increases and bleeding reduces. Okay. What is bleeding? Bleeding is a autogeneous flow of water on surface of concrete due to over vibration. Okay. What is bleeding? Wait, what is bleeding? Bleeding is autogeneous flow of water on the surface of concrete due to over vibration. Okay, due to over vibration. Okay, so now finest test of cement is basically performed by two methods. One is a sieve analysis and another is air permeability method. So finest test is performed by using two methods. First one is sieve analysis method. Okay, sieve number 9 and 90. Okay, and another method is air permeability method. Okay, and nurse and planes and air thermometer. Okay, so first we used to discuss about the sieve analysis, the finest test by using sieve analysis method. Okay, what we do in sieve analysis. Okay, what we used to do in sieve analysis is we used to take 100 gram of cement to be test is taken and kept on a sieve. Okay, we used to take 100 gram of cement to be test is taken. We used to do to test on this 100 gram of cement which is taken. Okay, and kept on sieve and kept on sieve is a number 990. Okay, then we used to do shaking is done for 15 minutes. We used to done shaking by manually or machinery, or by using mechanically or manually. Then we used to note that residue should not be more than that of 10, that should not be more than that 10%. Okay, and this test shows size of cement particle. And the sieve analysis basically shows the size of cement particle. Then what we do, shaking is done for 15 minutes. Done for 15 minutes. Okay, it is done by manually or machinery or mechanically, sorry, mechanically. Okay, then we used to noted that residue should not be more than, residue should not be more than 10%. Okay, more than 10%. Basically this test shows the size of cement particle. This test shows the size of cement particle and particle. Okay, the size of particle is less than 90 mil. This method is insignificant. Nowadays this method is discarded. Okay, this test shows the size of cement particle, and the size of cement particle is basically less than 90 mu. Okay, basically is less than 90 mu, and basically this method is not used on, not taken in this time. Okay, this method is discarded nowadays. Okay, nowadays this method is discarded. We used to take another method. Nowadays we used to take another method, which is permeability method, which is very useful. Okay, now we move on the permeability method. This method is sieve analysis. Sieve analysis is a method to determine the size of the cement. Okay, and permeability method is used to determine the surface area and specific surface area. Okay, and specific surface. Okay, and we move on the permeability method. Permeability method. Okay, what we determine in this, surface area and specific surface. Determine. Okay, let me draw some diagrams for this test. Okay, we have a block like this. Is a flow meter, is a manometer. Okay, so this test consists of apparatus of nurse blends air parameter. Okay, and air permeability method represent the fineness of cement in the terms of a specific surface, using the concept using the relationship between the flow of air, surface area of cement. Okay, so as we discussed above, air permeability method represent the fineness of cement in terms of specific surface and surface area. Okay, by using the relationship between flow of air, surface area of cement. Okay, this test, so first this test consists nurse and Blaine's air thermometer apparatus, apparatus of nurse and Blaine's thermometer. Okay, Air permeability, it represents the fineness of cement in terms of specific surface area. It represents fineness of cement in terms of specific surface area, specific surface, using relationship between flow of air, relationship between flow of air and surface area cement, air and surface area of cement, okay. Let me draw another diagram for understanding purpose of this permeability method for determining a fineness test. Okay, we used to fill here cement. This is the cement. Okay, it is about 20 mm. Okay, and here we have a flow meter. It is something like this. For diagram, you basically use the internet for better understanding. Okay, this is a simply sketch view of diagram. It is flow meter. Then here manometer. I'm sorry. Basically, it is a manometer. This is not a manometer. It is a manometer. Sorry for that. Okay, I have applied here. Okay, so what we done here, what we get from this diagram, here we have a 20 mm thick cement layer. 20 mm thick cement layer is placed on the perforated plate having size of perforation about 40 mm. Here we have, this is the perforated plate having size about 40 mm, having size about 40 mm. Okay, and from the base of the perforation there is blowed here, this one here blowed. From the base of the surface area there is blowed. A manometer is attached to base. Okay, a flow meter is also attached to permeability cell. Then after this, then we used to get pressure H1 and H2 are noted with the help of manometer and flow meter. We used to note the pressure H1 and H2 with the help of manometer and nometer. We get H1 from the manometer and we get H2 from flow meter. Okay, then the surface of area of cement is given by the formula. What formula is that? S is equal to 14 upon d 1 minus mu under root a psi square upon kl under root h1 upon h2 into. Okay, this is formula for surface area of cement. Okay, note that the procedure of doing the permeability test, what we do, 20 mm thick cement layer is placed on a perforated plate, plate having size about 40 mu, size about 40 mu. Okay, from the base of perforation air is blowed, from the base. Okay, and we used to connect a manometer and a flow meter. Okay, a manometer is connected from base, and a flow meter is also connected, and then we used to note the pressure H1 and H2. Note the pressure, note pressure H1 and H2. So H1 and H2 with the help of manometer and flow meter. We get H1 from manometer and H2 from by reading flow meter. Okay, then the surface or area of cement is given by the formula as we discussed above. Then surface area of cement is given by formula. Once again we write the formula is S is equal to surface area is equal to 14 upon d1 minus mu under root a psi square upon kl and under root h1 upon h2. Okay, one thing is which is most important is where d is equal to density of cement which is about 1460 kilogram per centimeter cube. Okay, size our porosity cement which is about 0.975. Okay, and A is our area and here A is our area, and L is our thickness of cement, and H1 is our manometer reading, and H2 our flow meter reading. Okay, and clay is our flow meter constant. Look, it is flow meter okay, so this is we used to done here. Okay, watch this video once again. In this video we used to discuss about the fineness of cement. In further lectures we used to discuss all these points. In next lecture we used to discuss about the consistency test. Okay, watch this video again. Till then, take care, good day, thank you so much.